Good morning, everyone. Today, we were discussing a fundamental topic in A-level chemistry related to atoms, molecule, and stoichiometry. This is a crucial area of study, and understanding it thoroughly will provide a strong foundation for more advanced concepts. Let's get started. Relative masses of atoms. There are more than 100 chemical elements, and each element is made up of atoms. The atoms of different elements differ in size and have different masses. The center of an atom is called the nucleus. It contains two types of particles, namely protons and neutrons. The tables illustrate protons have a positive charge, the same mass as neutron, and are found in the nucleus. Neutrons have no charge, the same mass as proton, and are also in the nucleus. Electrons have a negative charge, very little mass, and orbit around the nucleus. The mole. Atoms are too small to weigh individually, so we compare them by using a large number of atoms. This large group is called a mole, which contains 6.02 multiplied 10 to the power of 23 atoms, known as Avogadro number. This number makes it possible to measure the mass of atoms in a practical way. The mass of 1 mole of an element in grams matches its atomic mass in unified atomic mass unit, and it is based on the mass of carbon-12. Questions. How many moles a given mass of an element or compound represent? In order to do that, you need to know the relative atomic mass, AR, of the element or elements present. Information from the periodic table. The answer to the question A, to find the number of moles of a given mass of an element by using this formula. Moles is equal to mass divided by molar mass, where molar mass, also called relative atomic mass, which is AR, is the mass of 1 mole of atom of the element typically given in grams per mole. 6 grams of carbon. The molar mass of carbon is approximately 12 grams, and mole of carbon, by using the above formula, moles equals to mass divided by molar mass, you get the value of 0.5 mole. So 6 grams of carbon represent 0.5 moles of carbon atom. Question 2. How many grams of substance are in the following? So from the formula, moles equals to mass divided by molar mass, when the question is asking about gram of substance, so you need to find a mass where moles have to multiply by molar mass. 0.2 moles of neon is, the molar mass of neon is approximately 20 grams, and the mass of neon is 0.2 multiplied by 20, you get the value of 4 grams. So as a conclusion, 0.2 moles of neon represent 4 grams. Mass spectra. Another way of determining the atomic mass of an element is to use a mass spectrometer. You do not need to know how the instrument works, only that it produces positive ion of atom or fragment of molecules and separate them according to their masses. On placing a sample of an element in a mass spectrometer, atoms of the element become positively charged and separated according to their masses. Many elements are made up of atoms with the same number of protons but different number of neutrons, meaning that they have different masses. Look at the graph above, where on the left-hand side is represent abundant, and the below part is represent total number. And the data can be used to calculate the average atomic mass of the sample. And the average atomic mass of the sample of magnesium is made up of the contribution relative atomic mass, which is AR, equal to 24 times 0.29 plus 25 times 0.1 plus 26 times 0.11, you get the average or relative atomic mass is about 24.32. Let's look into the empirical and molecular formula. Empirical formula show the ratio of the number of atoms of different elements in a compound. You need to know how to use the composition by mass of a compound, divide the mass or percentage mass of each element by its AR, and use the date to calculate the simplest whole number ratio of atoms. Below is a question on how to derive empirical formula of chloride. Question: a chloride of iron contains 34.5% by mass of iron. Determine the empirical formula of the chloride. To get the value of or the result or the answer for empirical formula of chloride, you have to follow the following step. Step 1, assume a sample size of 100 grams and this simplified the calculation since the percentage mass of iron and chloride were directly correspondent to the mass in gram. Mass of iron equal to 34.5 gram and mass of chloride is equal to 100 gram. Divide 100 gram minus 34.5, you get the value of 65.5 gram. Step 2, you have to calculate the mole of iron and chlorine. To find the number of mole, we divide the mass of each element by its molar mass. Molar mass of iron is 55.85 gram. Molar mass of chlorine is 35.45 gram of mole. And mole of iron is 34.5 divided by 55.85, you get a value of 0.617. And mole of chlorine is 65.5 divided by 35.45, you get the value of 1.85 mole. Step 3, find the mole ratio. Divide the mole of each element by the smallest number of mole to get the simplest ratio. Mole of iron is equal to 0.617. Mole of chlorine is equivalent to 1.85. And now you have to divide each element by the smallest number of mole. So first we start with the iron, 0.617 divided by 0.617, you get the value of 1. And chlorine, 1.85 divided by 0.67, you get the value of 3. And finally, step 4, you have to write the empirical formula. So the ratio of iron to chlorine is 1 to 3. So the empirical formula of the iron chloride is FeCl3. Let's look into the molecular formula. Molecular formula of a compound shows the actual number of atoms of each element present in the compound. The molecular formula is always a multiple of the empirical formula. Question to calculate molecular formula for CH2O. A compound has the empirical formula CH2O and a molar mass of 60. What is its molecular formula? Molecular formula of CH2O, you have to follow the following steps. Step 1, calculate the molar mass of the empirical formula. The empirical formula is CH2O. Calculate its molar mass by adding the atomic masses of each element in the formula. So, in the CH2O consists of carbon, hydrogen, and oxygen. Carbon is 12.01, hydrogen 1.008, and oxygen is about 16. So molar mass of CH2O is equivalent to 30.03 gram. Step 2, determine the factors and to convert empirical formula to molecular formula. The molecular formula is multiple of the empirical formula. To find this multiple, we divide the molar mass of the compound by the molar mass of the empirical formula. Given the molar mass of the compound is 60 gram, so N is equal to molar mass of the compound divided by molar mass of the empirical formula. Step 3, calculate the molecular formula. To get the molecular formula, we multiply the subscript in the empirical formula by the factors N equals to 2. Molecular formula is equal to CH2O and in bracket 2. So you get the value of C2H4 and O2. As a conclusion, the molecular formula of the compound is C2H4O2. That's all for today's presentation, and that concludes today's session, and I look forward to seeing you at the next session. Please subscribe to Jom Studylah YouTube channel, and don't forget to turn on notifications so you don't miss any update. Best of luck in your studies, and wishing you every success. Thank you very much for your support.